Hello everyone. Today we will discuss the again important topic, which is most probable velocity, root mean square velocity, and average velocity. So in this content, we have again four kind of content. First, we will introduction the molecular velocity. Then we derive the most probable velocity, discuss the most probable velocity in detail, and also derive the Maxwell. Then its derivation of the most probable velocity from the Maxwell equations. And then we will discuss the root mean square velocity with its derivation from the Maxwell equation. And it last we have to discuss the average velocity with its derivation from the Maxwell equation. For the most probable velocity, we already defined the velocity with the maximum number of particles in a gas moving at constant temperature. In graph, you can see this is the most probable velocity, and this is the average velocity, and third one is a root mean square velocity. You can derive their relation by using this graph. For the most probable velocity, we have equation Vmp is equal to 2RT over M, that is R general gas constant, T is a temperature, and M is a molar mass of a gas molecule. For the derivation of most probable velocity from the Maxwell equation, we have Maxwell equation, which is 1 over n dn over du is equal to 4 pi m over 2 pi r d 3 by 2 u square e power minus m u square over 2 rt. For the slope of a curve, we can say that dy over dx is equal to 0, or slope is equal to 0. Then the whole equation will be equal to the 0. For a constant term, we can only make a derivation of this term, and that is a constant term. So we can only take a derivative of a variable term, which is e power minus mu square over 2rt u square. So we have to make a mathematical relation, which is make this one e power minus m u square over 2rt, which is first function, and we can call u square is a second function. So we apply a mathematical relation, which is that first function same, plus derivative of second function, first function same derivative of second function, plus second function same derivative of first function. This is we have applied a mathematical relation, and then we have taken a common in this step. We have common this e power minus m u square over 2rt, and then we have divided on this equation by from both sides, which is u power minus mu square over 2rt. Then we have simplify this term, and then we have got a final relation, which is u is equal to 2rt over m under root, which is most probable velocity relation. For the root mean square velocity, we can define the square root of average of the square of the velocity is known as a root mean square velocity. Here is their mathematical expression, and here also R is a general gas constant, T is a temperature, and M is a molar mass of a gas molecule. For a graph of a root mean square velocity, you can see that is a root mean square velocity in the graph. And for its derivation, we have from the Maxwell equation, we can derive the root mean square velocity. U square is equal to u1 square plus u2. That is velocity of a molecule, first velocity of a molecule. This is velocity of fraction of a molecule which is moving with the v2. That is also a fraction of a molecule with moving with the speed u3, plus there is a lot of velocity up to u square un square. So we can express this whole relation into smash form, sigma form, and then we can also express this sigma form into that integration form. Then we have take this multiply and divide by du over uh, du over du, multiply and divided by du over du. Further we have we make this some term with equal to 1 over alpha. We have put some term like m over 2 rt is equal to 1 over alpha. Then we have integrate and make a relation, and the integration of u4 e power minus u square over alpha square du, which is equal to 3 by 8 alpha 5 pi 1 by 2. And then we have simplified this equation and get the final relation, which is equal to u is equal to 3rt over m under root, which is most probable velocity of a molecule, gas molecule. And thank you for the watching our video. We are together for next lecture. We will together very soon for the next lecture.